I think I just fried something. I am kind of concerned about an issue. The neutral wire and the positive wire that go to my battery are really, really close to each other. And if they cross, they're going to short, and it's a fire hazard. It's actually pretty dangerous. So I need to figure out a way to make that safer. I don't know what to do yet. I have a bit of an idea, but I need to isolate them and so that they don't cross. Because if they cross, it's dangerous. Like I either need to isolate them, or I need to find some device that will basically turn the power off if it detects a short. So I ended up reprinting this irrigation controller. While I was reprinting it, I added this, I don't know what you want to call it. It's kind of a bit of a bump out where I can mount this plate to it. And what it is a T-post will come through this hole, and it'll sit like this. It'll basically lock into place on that T-post. And then I'll have the solar panel on this one. So the first thing I need to do is hammer in that T-post. Then I can basically put the box on it. For the risers, I have this little head here. It just has a 1/2 inch thread on it, and then 4 1/4 inch, I don't know what you want to call them, outlets. And they just screw directly on top of those risers. For the pipe, I have this 1/4 inch pipe. It's just a plastic pipe, and it already has the emitters every 12 inches, I believe. No, it's every 6 inches. And what I'm gonna do is I'm gonna have 3 lines of these in each long bed, and then I'll just have 1 line coiled in the round beds. And the idea is that it will just evenly soak the entire bed. At the end of each of these lines, I'm gonna put a goof plug. These goof plugs are meant to fix mistakes, hence the name goof plug, but they'll work just as fine to just shove in this hole here at the end and basically block the water flow. Now that all the irrigation is in the beds, I can connect the sprinkler wire to the irrigation controller. I'm using 2 5-strand sprinkler wire lines, and so each line has 5 individual wires in it. 4 of the wires carry the switch leg from the irrigation controller, and then the 5th one supplies the voltage or the power. They just need to be mounted on this PCB board through these blue blocks.
Oh my god, Izzy has a full-size...
Oh my god. I don't know how you got that chicken.
I got it when I eat it.
And there's 8. All right, cool. Oh no. I think I just fried something. I did not. All right, cool. I need to figure out how to make this so that they don't short. Huh?
Put it back on, Dada.
I got all the wires in the box and everything hooked up. It is working. I did verify it. But I am kind of concerned about an issue, and the issue is that the neutral wire and the positive wire that go to my battery are really, really close to each other. And if they cross, they're going to short, and it's a fire hazard. It's actually pretty dangerous, even with the 12-volt battery. So I am going to finish the setup here because I'm in it, and I may as well finish it. But I'm gonna leave the battery disconnected until I can figure out how to solve that problem. But everything works, and that's a good sign. So this solar panel that I have mounts to this bracket, and there are little holes on the sides of it that mount to the side of the solar panel. I'll get to that in a second, but I'm using this scrap piece of 2x4, and I've just screwed this bracket into it. And what I'll do is I'll take that T-post bracket, and I will fasten it to the back so that it sits on the T-post. And I can, you'll kind of see, but I'll be able to change the position to some extent of the solar panel to capture the best light. Basically what I have here is I have a solar panel with a charge controller on it. And this charge controller will hook up to the battery, and it will basically just keep it topped off. It's a trickle charger is what it is. There's not a lot to it. It's a solar panel with a charge controller that I hook up to my battery. That's all it is. So I think I got it figured out here. There are two things that I am trying to solve. One, I am trying to physically isolate the leads that plug in to the irrigation controller and come from the battery. And two, I'm trying to shut off the power when a short is detected. And I think I've solved both of those problems. So for isolating the leads, what I'm going to do is drop this thicker gauged wire to a smaller gauged wire so that I can put it into a connector and plug that connector into the breadboard. This is generally not the greatest idea because the wires that are running from the battery to the irrigation controller are bigger and can handle more current, and the smaller wires cannot. And so what could end up happening is if too much current is being pulled from the system, those smaller wires can overheat, even though the bigger wires may not, and cause a dangerous situation like a fire, or just more really just melt and get very, very hot. What I have done is add an inline fuse holder that sits in line with the positive terminal or the positive rail, whatever you want to call it. And this fuse will blow if more than 2 amps is pulled through this fuse. Each one of my valves only pulls about 1/3 of an amp, and I'm only going to run really 1 or 2 at a time, so I'm totally good. And more importantly, the wire, the smaller gauged wire that I step down to, can definitely support 2 amp current at 12 volts. So that problem has been mitigated. Also, what this fuse can do is not detect a short directly, but indirectly it will cut power when there is too much current or when a short does occur. And basically what happens with a short, like a dead short, which is what I was concerned about, that's when you almost physically directly touch the hot wire to the neutral wire, is that an insane amount of current flows through the battery, through the system, and that's what makes these get very, very hot and potentially cause a fire. Now that sudden increase in current, amperage, will blow this fuse and basically cut the power to the system. So I've solved what I believe is the biggest issues or the biggest risk with this, which is one, detecting when a short circuit exists and cutting power, which we are doing through this fuse, and two, physically isolating the leads in order to reduce the chances of a short circuit, which I have done by stepping down the wire and putting it into a connector which plugs directly into my breadboard. I ended up printing an enclosure for my battery. I couldn't find any in the stores that fit this specific battery size, and it was easy enough to print, so I just did it. I think it's waterproof. The wires kind of come up through the back and then loop down into the actual battery. As far as I'm aware, the water should just shut off pretty naturally, so I'm not going to worry too much about it. But once I get this hooked up, the controller will have power, and the battery will be charged by the solar panel. So that's basically all I have for this garden. I'm going to consider this project done. I know I'm going to tweak it over the summer and probably into the fall, but there's not a whole lot that needs to happen right now. I have the controller working. The controller is on. It controls all 8 valves. I have the irrigation hard lined into my water supply. I have it coming through every bed, and I have the drip hose on every bed. I'm sure I'll also change some of the drip lines through the year as I either plant my vegetables for fall, or if I see that some plants aren't being watered enough or they're being watered too much. So it's going to be this continual back and forth until I start to learn and start to understand what the plants actually need. I still need to work on some of the software. It doesn't have all the features that I would like, but I'll just do that as I do it. It's not enjoyable to watch me write software, so I'm not going to video it. I'll probably just do it and do it as I need it. But yeah, this is I think the extent of this project. It was quite a bit of work. It was enjoyable work because it was a mixture of physical work and mental work, which I really enjoy. And the biggest benefit is that it will help me out. This is why I like to do automation, not just for the sake of doing automation, but for the sake of getting something in return, which in this case is time and a reduction of that mental load. I'm excited to see how this garden pans out.